All right. Well, welcome everyone. Welcome to the online audience again. We're going to continue with the next talk. It's by Bart Oldeman. Bart Oldeman works at what is formerly known as ComputeCanada, now is known as the Alliance. And they have a solution which is, well, actually, we have a solution that is kind of similar to theirs. Let's give credit where credit is due. And I think, I hope what we'll hear is what they do differently and get some inspiration or some motivation of why we do things different from Bart. And of course, have a nice discussion. So with that, Bart, I will give the floor to you.
Okay, thank you very much. So my talk was introduced as the Compute Canada side talk, except that Compute Canada doesn't exist anymore. And the whole renaming exercise, if it's confusing for me, it's probably even more confusing to you. But in the end, the Compute Canada is morphed into what's called the Digital Research Alliance of Canada. But that officially is only a national coordinating office. It's a non-profit organization funded by the government of Canada. And so I am not directly employed by the Digital Research Alliance of Canada. My direct employer is McGill University. And also we talk about the Federation, which is the national office, but also 38 partner universities and 5 regional organizations. So every university working with the Alliance is also part of a regional organization. In my case, that is Calcul Quebec. So in turn, Calcul Quebec is then a regional partner of the Digital Research Alliance of Canada. And of course, in Calcul Quebec, we collaborate a lot, especially in terms of teaching workshops, and also the operation of the 2 big clusters in Quebec is done by an operations team for Calcul Quebec, which consists of employees of different universities. So I myself am part of a research support national team, which is coordinated by the Alliance as a software installation coordinator. I'm not the only software installation coordinator. We're also having Charles Coulomb and Doc Roberts. So Charles is mostly on the Python side of the software installation, which I'll get into a bit later. Doc Roberts looks at licensed software like ANSYS, Star CCM Plus, and other somewhat tricky to configure programs. Maxime does a lot of the software side. He's the coordinator of the Research Support National Team. And then, of course, we have Ryan Taylor, who's doing more of the CVMFS side. He is given a talk yesterday also, which you may have seen. So that's about our side of the people work on it. Now there are also other people on the RSNT and even outside it that install modules on our software stack. One last thing, if Federation and Alliance makes you think about science fiction, you're not mistaken. There was an alliance of the Federation and the Klingons and the Romulans when they were fighting against Dominions in Deep Space Nine. So if it rings a bell for Star Trekkies, that's very cool. So just to give an idea about what it looks like in Canada, there are 5 regional organizations. So we have Calcul Quebec, where I work. In the east, there's AceNet. We have Compute Ontario for the province of Ontario. And then in the west, we use the West Grid. That's now been split into the BC and Prairies digital research infrastructure groups. They've been officially split, but they still work together, and together they call themselves West DRI now to make things complicated. And so BC is for the province of British Columbia, and Prairies is then Alberta, Saskatchewan, Manitoba. So what we have done is overall about 250 technical staff just distributed all over the country, about 18,000 user accounts, and 6 large clusters that are national clusters, so that every researcher can have access to it. There's also some institutional clusters which are smaller, much smaller than this that we're talking out on the site. So we support a lot of disciplines. There's like 10 years ago, it was still fairly traditional, a lot of computational fluid dynamics, physics, and weather forecasting, all traditional stuff. But it's been huge growth in less traditional disciplines. There's been growth in digital humanities. We're also having much more on storage and research data management, all that stuff that improve that makes grow in different directions, which are not always traditional HPC. So about 5 years ago, everything started to be reorganized from having the big universities each having their own clusters to having 6 national systems, of which one, Arbutus, is a cloud system, and we have 5 bigger HPC clusters, of which Niagara is a large MPI clusters, and the others are more general compute clusters. Cedar and Graham were from 2017. One of them is OmniPath, the other one has EDR, so InfiniBand, and then we have 2 clusters in Quebec, in Montreal. The oldest one is Beluga, went into place in 2019, and then Narval. So Narval and Beluga are now in the same data center. They are right next to each other. I just walked through that place last week. They are very noisy mammals, and Narval has AMD chips, and Beluga has Intel chips. That's their main difference. So with the distribution, it means that we have large data centers, but there are also some universities that don't have a physical cluster, but they still have people working for them who may be doing system administration or user support. So the next couple slides have a lot of overlap with Easy. This is so I can go for them quite quickly, but then at the end we're going to get a few more technical slides about the differences. So we wanted in 2016, we wanted basically a consistent interface to all the users. So no matter what cluster they log into, they can see the same set of modules. So if they have a job script that runs on, say, Cedar, they could run the same job script on Beluga without having to change everything. All the module load commands are all the same, and the software will also work pretty much identical, unless there's some weird architecture difference. But even then, if they can load the AVX2 module, make it identical to the other clusters. So we have it independent of the OS. So similarly to Easy, we have the compatibility layer. We now use Gentoo prefix, but we started out with Nix. Of course, we use EasyBuild as well, and Elmod. There's nothing new here. The background is also that often the software stack that's installed on clusters is too old. So many of our clusters still use CentOS 7. That is starting to show its age. It has a very old CCC 4.8, old glibc, older Python that is no longer supported. Red Hat 8 is already a lot better. Red Hat 9 is very, very new, but almost nobody uses it yet because well, the vendors have to catch up. So basically, we are always dependent on clusters for vendors who need to have their Lustre drivers, etc., to certify it on enterprise Linux distribution XYZ. But of course, users, and especially tech-savvy ones who run like Linux on their own laptop, will use a very new Linux distribution, and they want to have the same experience on the cluster. So that's not often not quite compatible. For that, we have users reading instructions on various web pages of their favorite software, and often the wiki of the particular software says, oh, in order to run this software, you first need to install some dependencies. So in order to install the dependency, you need to run sudo apt-get install xyz. So they type that in on the cluster and they see a whole bunch of scary text. And then they ask for their password. So they type in their password, and sometimes it says, this incident will be reported. And then we get a very apologetic email saying, sorry, I've been reported. I just tried to follow the instructions of website XYZ. And I hope you won't give me into to the government or the police. We say, don't worry about it. We have other methods to get your dependencies. So you can just load a module. Traditionally, these modules were installed by hand, as was mentioned before. Spend too much time on this because discussed a lot as the reason of existence for Easy as well. So how to not become invaluable, EasyBuild. In a sense, we want more job security, so we should become invaluable, but for the greater good, it's better to not become invaluable. Here's the design overview. So this is very similar to Easy, but here is where we see a few differences. So just like in Easy, we have the layered approach. We have the EasyBuild layer with the modules. We have multiple architectures, not exactly the same as in Easy, but we have basically four architectures that we support. So SSC3 for a very old cluster that's been decommissioned. I think it's pretty much dead now, except for a few nodes. AVX, there's a few departmental institutional clusters that still need that, but all the national clusters support at least AVX2, and then there's a few with AVX 512, Niagara and Beluga. We don't do any subdivision in that. We don't do a special Zen2 or Zen3 branch, although a few performance sensitive libraries like Blizz, I have compiled as fat binaries like Blizz and OpenPlus, where they can distinguish between Zen2 and Zen3 and get different code paths on those sensitive libraries. Get some speed up on AMD chips. And this is all in a path. And so because the name soft.ComputeCanada.ca is literally everywhere in the stack, we didn't change this ComputeCanada to AllianceScan.ca because it's just unworkable and there's no good reason to change that name. And under this directory, we have two directories, modules and software, and then under there we have 2017 for the older stack and 2020. And we used to start off with Nix, but now we have a Gen2 prefix layer, and our Gen2 prefix layer at the moment is a little bit bigger than the one provided by Easy at the moment. Maybe it will grow for Easy, but at the moment we're comfortable with that size of our layer. And this is in turn loaded by a manually written module. So we basically do module load Gen2/2020, and that will bring a set a lot of environment variables. One very important one is the ePrefix environment variable that is set to the Gen2 prefix. And we also have another one, EBRoot Gen2, which is the prefix/USR. So it's kind of can be used as EBRoot environment variables for regular EasyBuild modules. So it helps us out in cases. Then we have a gray area that we do mostly in Gen2. It's kind of a little hard to say where's the boundary between the compatibility layer and the host OS. Mostly we have all the libraries that are used by the compatibility layer that are in the compatibility layer. We don't use libraries from the host OS. There's one exception is libcuda, but the rest is all taken from the compatibility layer. And that works well enough. We don't have to use the host OS client libraries for independent panels. It can be done if you want to. we don't. And then we have at the bottom the OS kernel, of course, that needs to be privileged, the daemons, and some things that we're not allowed to install in CVMFS, like FASP, that has to be installed directly on the cluster by licensing. CVMFS, so we have a stratum 0, multiple stratum once distributed along Canada, and then every cluster has their squids, so things will be cached locally. Unless you have something that's rarely used, then you may have to wait a bit until it's in the cache, but things in the compatibility layer are always available because they're always cached pretty close. So for the Gen2 prefix, we have those EasyBuilds, and we installed a lot in our Gen2 prefix, and a little bit more in EasyBuild, than Easy. So Easy is basically what you get from a bootstrap of the prefix and then installing some basic infrastructure for the network fabric and a few other things like Elmod, and a few editors. Now, well, we installed a few more editors, but we also have a whole made desktop, LaTeX distribution, Tech Live, Pandoc, and pretty much a bunch of non-scientific tools that consist a fairly typical Linux desktop. Well, in so far that we want to support made via VNC. We don't install web browser, we don't go that far, but we go a bit further than the easy layer. Of course, installing a web browser is of course useful on a desktop, but we don't want people to run Firefox on compute clusters because they are resource hogs and they just bring down your login nodes. So then the advantage is that we have newer versions of those then found in particularly in the older enterprise distribution. So Elmod, everybody's familiar with Elmod already, so not much time on it, but we have that too. We have, unlike Easy, we have Elmod at the very bottom because we want to support both the older Nix environment and the newer Gen2 environment with Elmod. So we have Elmod compiled manually and then have it completely at the bottom, and it only depended on the system glibc, an older one from CentOS 6 even. So this is one small difference that we have Elmod at the bottom. But if you only have Gen2 prefix, then you can have Elmod in the compatibility layer. So conceptually, how we do things is that we have all the relevant repositories in Git. So we have on the ComputeCanada GitHub, which is still named ComputeCanada. We have forks of all the relevant repositories. For Nix, we had a fork of Nix package repository. For Gen2 overlay, it's a separate Git repository with some of the recipes for Gen2 that we modify. And then for EasyBuild, we have a fork of framework, EasyBlocks, and EasyConf. There's pros and cons of having a fork. Some sites have just or something like an overlay for the EasyConfigs and EasyBlocks, where they only store the ones that are different from the upstream EasyBlocks and EasyConfigs. That's also a way we could do it, but so far we've just been working. And then every time there's a new EasyBuild release, we do a merge and our EasyBuild. So here's something that Kenneth asked. So how do we install software? This is more manual than on Easy. This is something we could learn from Easy, is that Easy is doing a lot of automation that we haven't done that far. course, we benefit from the automation from EasyBuild itself, but basically that's where it stops. So first, when we have a user saying, I need software, we figure out whether it should be in Gentoo and EasyBuild. So basically we say, is the software performance critical? Depends on the MPI, or is it somewhat scientific? Then we put in the EasyBuild. If we have multiple versions, if we anticipate multiple versions needed via modules, we also put in EasyBuild, and if not, we put in Gentoo. Now that particular question isn't always exactly clear. I'll mention a few examples later. Like for instance, we used to have GNU plot in the compatibility layer earlier, and then we said, I know this is more scientifically oriented, so we EasyBuild layer. Then we installed on our build node. So we have basically we have 2 build nodes, and anyone can do a test build on the build node via regular EB. So when you just do EB some easy config, it will install it in your home directory under .local/easybuild. Same. And so when we are as an analyst working on the easy config, we always try to first install in our home directory. Then we can do module load that software, and it will, if it works okay, then we do the same command again with sudo -iu ebuser, and then there's the central ebuser privileged user that will install it centrally on the build node. Then we can load the module from the central location. We can test it. If it works okay, we can deploy in a dev repository. Then we can test again on a VM that mounts that, or with proot on a cluster. Sometimes we skip 5 when it's a completely new module. There's no point testing it on dev because you need to load the module anyway to get it in production. Then we deploy in production repository. A couple commands you need to type to deploy it, and then we can test it on the production cluster. So each of these steps, they involve about 3 commands. So there's a bit of automation that could happen. Like we have to git push the recipe into our fork. Then we need to pull it into the central repository. Then we run EasyBuild. So those steps, they could be more automated. Like you could, for instance, think, okay, once you do git push, there could be a trigger to a whole mechanism which installs it automatically. But we do it a bit more manually, and that has its pros and cons. The manual also means that if there's a mistake unexpectedly with the central one, then we can just do IU ebuser again and don't have to get via some interface on the API style system. Why did we change from Nix to Gentoo? So Nix has a fairly well-designed structure where every package is installed in its own root, which has a hash, and then you could combine that into a profile where you could see everything combined. But everything in itself is a symbolic link to a particular hash directory. Now, sometimes the symbolic links were resolved, and then we would see the hashes. But if we do an update of a particular piece of software, then the hash would change, and you could do a garbage collect. The old hash link would disappear, and you would get breakage. This would not typically happen in a Nix environment where you only use Nix and not EasyBuild on top, because in that case, everything is consistent and Nix is the only thing you work with. But we found out that EasyBuild on top of Nix wasn't working very well for those kind of cases. And Gentoo prefix was like no symlinks, no store leak, a minimal solution. Another thing we're doing is that Python, our Python modules are pretty minimal. They only install the bare minimum of packages that we need to basically make use of Python wheels. So when you do module load Python, you don't have the long list of extension modules that come with standard EasyBuild Python. But instead, we have a very long list of wheels. So people basically are instructed to start a virtual environment and then install the packages they need with pip. And this will basically copy or unzip a wheel that's installed in our repository instead of having to download it from the internet for most common packages. If it's not in our repository, it will still download it from the internet. And by this time, we have over 15,000 wheels installed over the years. And there's a command called avail wheels that shows you which those wheels will have. So for instance, if we want TensorFlow, we don't do modulo TensorFlow. We get a virtual environment, then we do pip install TensorFlow. And at this point, we get TensorFlow 290, for which we have a wheel available for Python 3.8, 3.9, and 3.10, which are presently our supported Python version. We have just stopped supporting all older Python versions. They still work, but you don't have the same newer wheels anymore. This is kind of what has happened over the years. We moved the number of software packages up to we're nearing 10,000 modules in total. But of course, there's about 1,000 individual module names. It's just lots of formatations of versions, CPU, tool chain architecture. So we thought we had a nicer solution with Gen2 prefix, but the problem was that Inplace updates then happen. Instead of having symlink forest, we now have an update that is actually in place, and we found out that that is sometimes problematic. So we have one war story, which is known as CVM 2001. It's a CMFS bug. I'm not sure if it was discussed yesterday or the day before, but it was a fairly big day when that happened, because we had a fairly innocent looking change to enable memuses stat for memory profiling tools that changed the glibc library. We pushed it and boom, everything started crashing, and it was pretty bad. And we found out that if we did a stat 256 sum on that file, on the glibc binary, it would give different results every time you ran it. So we submitted a bug report. Jacob Bloma has been working on it for a long time, and finally a fix was found, and it was committed to CMFS Git 5th of September, so last week, and it should be in the upcoming CMFS 2.10. We can sort of avoid it for now with if we use symbolic links instead. So instead of updating a file in place, we can replace it by a symbolic link that points to a different file. Or if the file is always read via symbolic link, we change the symbolic link to point to a different file. A couple other challenges that you'll see with Easy or any other thing that use a custom prefix is mostly with users that download software binaries from the internet. They say, oh, we download a binary from website XYZ and it doesn't work on ComputeCanada system. It gives linker symbol errors or things like that. So we have a script that patches the download binaries so they can work with the prefix. It's called setrpaths.sh. Sometimes there are users who set LD library path to user lib64. Sometimes the wrapper script is commercial software does the same thing. So we edit those wrapper scripts. Those will break most tools as well, so we should look out for that. And there are also issues with Anaconda and Julia to a lesser extent that they provide binaries. Sometimes you install Anaconda and you end up with your own private version of O or R that's not optimal, and so we actively discourage Anaconda to use. Sometimes everything else fails, and then we can work at the OS level, or we have to create or fall back to Singularity or Apptainer, run something that absolutely doesn't work with the software stack or is just too time intensive. So here are a couple differences with Easy and mostly challenges. So we have basically the challenges are mostly on the layer boundary. So there's two layer boundaries. There's the layer between the host OS and the compatibility layer, and there's the boundary between the compatibility layer and the EasyBuild layer. So one issue with the Gentoo prefix is that they want to use even a prefix /var directory, but there are other tools that write to the /var directories, and there's some utilities like lastwho that read files from the var directory, where daemons that of course run on under the host OS, they write to those files. So if you look into a default Gentoo prefix installation, it has a file part of glibc user include path.h that also prefixes the var run utemp file. So then when you compile a tool who, it will look into that file to see who's on the system. It sees nothing there, so it just gives you an empty list. And so that needs to be adjusted. So either we have to change path.h, which we haven't done. Instead, we put in some strategic symlinks. So we basically do a symlink from e prefix /var /run to the host /var /run, so that these tools can run. Now I've seen in the Easy Stack there's a ticket about that directory, but it's not been symlinked. So the who and w and last, they don't work properly on the Easy pilot environment. Otherwise, I've been I just the past week I've been bootstrapping a new version, an updated Gentoo prefix version, just to see how it works nowadays. Actually, it works a lot better than 3 years ago. A lot of e-builds have been fixed to work properly with the prefix much more than a couple years ago. So I could actually bootstrap much of Gentoo prefix with only very minor changes. I didn't even have to set up an overlay. I could just do some hook configuration with some econf parameters in special configurations files. If you want the details, I can give you a list, but it's a little bit too technical talk. And I could set up a made desktop without too much trouble. That's because Gentoo has e-login day, which is an alternative to systemd. So we don't pull in the whole systemd infrastructure, which is very heavyweight. Anything that involves libpam for access works fine. There's really nothing that adjusting on that. There's the part of the LDAP that is important because you want to see all your users, and so you want to have a proper mapping from a UID to a username that goes via either libnss LDAP or SSS on any cluster. We used to symlink that to the host library, but that broke once the host OS library was upgraded to CentOS 8. Then in some cases, the host OS was newer than the compatibility layer. In the end, we solved that by just compiling those in the compatibility layer without symlinking that. So we tend to avoid symlinking libraries from the host OS because that can break. Those two libraries are still symlinked in the Easy pilot. I think they should be compiled from source. So for mate, that worked without much trouble. The only thing I had to disable was something called udisks, which is a storage drive monitor, so that you can stick USB keys into your laptop and it will see them. So I had to strip that out because it really wants to start a daemon that doesn't work from the prefix. And we even have some SE Linux support, which was there, so that when we do ls with special parameters, we see some file system labels that are only supported by SE Linux. The other thing, like we have the compatibility software layer boundary. So that is managed also via filter depths. So Easy already has some some easy configs that are ignored in filter depths, which is a shorter list of 21 easy configs. And we have those same filter depths, but a lot longer list. So we also, on top of those more basic lower level build utilities, we add a whole bunch of libraries that are mostly about graphics and compression and X11, even some for their video decode. If you look, there are also some that have special symbols where we put it in the compatibility layer, but had to bring in modules after all, because the versions in the compatibility layer were starting to become too old. So we did that, for instance, for HWLock. We had it in the compatibility layer, and then we found out that the old version wasn't keeping up with some hardware, so we had to install modules for HWLock. Same with CMake, we had to also, couldn't just stay with 3.16.5. We needed some software, needed a new version of CMake. So there are some of these cases which are doubtful whether they should be in compatibility layer, and we ended up needing to change them to modules. Some other differences are in the 10.2 configuration. Easy started using something called sets, which is very useful in the sense that we don't have to just manually do emerge every time we add something and lose track of which software has been emerged or which software we're put in as a dependency. You just have a set of what you need. We should do that too. CC ComputeCanada has a software as a custom profile, which I think Easy could benefit from because it's properly put in Git. The arches are different, so Easy has a lot more in terms of architectures, where we are x86, even though we have a few sub-architectures for that. Easy has a flat module naming scheme with mixed case, which is the default. For EasyBuild, we have hierarchical with lowercase names. Easy is a lot more automated with Ansible, which we don't. We do manual execution of EasyBuild, git push and pull. So here we could learn from Easy. Another thing we do that benefits us, but is a little bit outside standard EasyBuild, is that we have a central location for runtime use of the lib standard C++ and libg Fortran and libraries like that, which are loaded via the standard Linux ld.so.conf mechanism, not via LD library path and not via our path. And so we have a very big number of modules that we install at the core level, even stuff that we install with GC core, no matter what version, they all get put into the core level. And everything is compatible with each other precisely because they have a standard runtime directory for the GCC libraries, which are backward compatible. And originally we put that in place because we had some Python wheels compiled with different versions of C++. And by having them all use the same lib standard C++, they were all compatible with each other. And they didn't start complaining about missing. Another thing is the RPath difference. So Easy uses Easy builds RPath functionality to compile software, and we use a lower level wrapper at the linker level. Neither set LD library path in modules, which is a problem for Easy, because if a regular user does C-L some software, some library foo.c, it won't work at runtime. Like I did an experiment myself on the pilot. I loaded libffi as a module. I compiled that simple foo.c program with the library, and it can't find it because I didn't put an RPath manually into this software. There is a promising alternative to this, though, which entirely avoids RPath. It came in only recently in August. So there's a guy who works in, a Dutch guy who works in Switzerland, Harman Stoppels, who has written a blog post where he wrote that instead of putting the absolute path as an RPath in the binary that you compile, you put the absolute path in the SO name in the library. And in that case, you don't have to put any special RPaths to the binaries. Everything gets inherited from the library. So you need to only adjust the shared libraries. Here's an example. You have a particular simple file that you compile into a shared library, and you set the SO name as the absolute name of the library. So this is the particular library directory where you compile in, pwd in this case was /tmp/hello, gets embedded into the shared library. And then I will compile a simple test program with just -lf, and the R path is not added to this particular binary. And then I can just execute. So the trick that's used here is that the needed, which is an entry for which library it needs, becomes an absolute path here. So instead of having a needed entry of simple libf.so and depending on the R path, it has the absolute path name of the library that's embedded in the binary that we have, and that basically avoids needing to use any linker wrapper or RPath settings. Instead, the work is shifted to creating the shared libraries. So I find it a really promising development because it saves a whole lot of effort. There is a pull request for SPAC where he wants to implement just that, which is open and they're discussing it. So this is something I want to consider for the future as well on our project, and maybe you'll find it interesting. So opportunities for collaboration. So as for Easy, we have the public part of the stack available everywhere. There's a wiki page about it. You can source a script much like for Easy. And we also have, next to the software repository, we have the proprietary package in the restricted repository, which only ComputeCanada or Alliance clusters can mount, and other people at Canadian universities who have certain conditions. They can mount that restricted stack. What we can do in terms of collaboration, I like the more the level of automation, and I think particularly the compatibility layer in ComputeCanada, what we're using is pretty much a superset of the Easy stack. So I think we can share a lot in the compatibility layer. It just needs a larger set and some extra Gen2 configuration, but there's a lot there we can share on that front. So that's about it for my talk. I hope this gives some food for discussion.
Questions, comments? Casper. Hey Bart, thank you for a nice talk. I was actually triggered by like the procedure that you showed, how you deploy software, and there were 2 test steps in there, right? So, well, actually 3, I think. Like first you test it locally, then you deploy it to the dev environment, you test it again, and then you deploy it to the production environment, you test again, right? So do you do this testing for every software package that you deploy, or?
No.
Like, how do you decide? I can imagine that you don't even know how to run some of these software packages.
Yeah, it depends on the software. Often we skip the dev step. We just go to dev and then to prod straight away. If there's a completely new piece of software, like if some user say there's some random bioinformatics tool that they want, we have a new module for it, and then we just as soon as it works on build node, we just push it to prod because nobody's dependent on that straight away. So the testing can be done directly on prod because we don't have random users loading that module from day one and then seeing it book into it. The only user that wants it is the one that has sent us an email about it. But if we have more critical software, like I have a new version of OpenMPI, I definitely go via all these steps. I make sure that it works on every level because those are things that pretty much everybody loads. So those go for some more thorough testing.
And do you do that testing sort of like in an ad hoc way? Okay, you know how to test MPI, so you just do this manually, or do you have like a fixed test suite that you run, or?
Yeah, no, this is something that we can improve. We did set up a reframe test suite, but it's not been very well maintained. was working pretty well 2 years ago, but I haven't looked at it for time.
Because I think it could be yet another point where we might be able to collaborate. For us, the testing is also a question like, what should we test? Should we test everything or a subset or, and it needs to be portable anyway between different systems. So yeah, maybe we can design one test suite that works for the both of us and share the effort.
Yeah.
I don't know.
Yeah, and
maybe it makes it more complicated, but maybe we can share effort. Let's see.
Yeah, there's a lot of testing even when we need to bring back a cluster like this. Like with Red Hat, we now for Rocky we had the issue with Intel MPI that we didn't catch, and we just need to get the right kind of test to also include Intel MPI in the testing. Catch that problem.
Yep. Okay. Thanks.
And I think there's one difference that you didn't highlight, and if I missed it, I apologize. But you're including quite a bit of packages in the compat layer.
Yeah.
And I think one of the reasons for that is that you essentially also expose that compat layer to the users. So they basically get all the tools that are installed in there as soon as they load your module or source your profile script or whatever. Need to check the power because it's running out. Plug it in now. So yeah, you're exposing all those tools from the compat layer to the user, and at least in my view, we don't want to do that. I think, and the compat layer is purely there, so we don't need to rely on the OS and any libraries like glibc is a prime example. We just pick it from there, and we are independent. And maybe this is a personal view, but I think the compat layer should be as small as possible, because that's actually the thing where security updates and things like this are important. So the less packages you have in there, the better, because the less likely that you'll have to update.
Yeah, that's
I mean, right now we have CMake in there. It doesn't make any sense to me at all.
Right. Well, you need CMake to bootstrap the compat layer.
Yes, but once it's there, you can chuck it out.
You can remove it. Yeah. Yeah. So yeah, this is something that we can remove from it.
And I mean, I guess
we actually ended up overriding it. Like we have a special custom directory where we have a CMake binaries in there that override the one in the Gentoo layer. So yeah, CMake is a particular problematic one, but we have the compat layer also pretty full because we have some clusters like Navarro in particular. They have very few OS packages installed. They have like memory images. So pretty much everything is taken from Civa Invest. So you can't really rely on the host for much of anything. So we have these things like the LaTeX installation, all these kind of standard Linux tools that are just not present in the host OS. So we have to rely on them from the.
So you're using the compat layer for more than just shielding the applications from the host OS, but also essentially providing a host OS.
Yeah, we're pretty much overriding the host OS apart from stuff that absolutely needs root.
Yeah. So drivers.
Root should not use the compatibility layer, but it's pretty much like anything that is in user bin on the host OS is overridden by stuff in compatibility layer.
Yeah, I guess that's something that's not clear yet for us. I mean, you could argue both ways.
Right. Yeah. Yeah, and so we really want to avoid, like on the build node, our user include is just empty. We want to really avoid doing that.
Can you go back? You had a remark somewhere that says to install multiple GCC versions in the software layer, you need to have multiple GCCs in the compat layer as well. I don't think that's true, because EasyBuild can actually to build GCC 10 with EasyBuild, you can include an GCC 9 as a build dependency for GCC 10. If you start with the lowest one first, you can just build your way up.
Yeah, no. What we want, we need the newest lib standard C++.
In the compat layer.
In the compat layer. Yeah. So once we've installed the one for 11.3, we can delete the one for 10.3 if we want to, because it's no longer used. Compat layer. But we need a newer lib standard C++. We need the newest lib standard C++ needs to be found by all the applications somehow.
Okay.
And so what we could also do is to just use a TCC from the compat layer. So basically use the method in EasyBuild provided TCC core system, like TCC core systems, like the system compiler EasyBlock, and make that happen. Like instead of compiling TCC from source in EasyBuild, we just use TCC Gen 2 because they also have different versions in parallel. So that's another way we could do that. And we've done that on Nix, that we use the TC from Nix. But one thing that we have that TC in Gen 2 still doesn't support is offloading to GPUs. So I'd have to get that working on the Gen 2 side to make that work properly.